Hello friends, welcome to my channel Maths Corner. Okay, so today we are here with an important Wilson theorem. So it's a very important and interesting theorem. So let us start with the Wilson theorem theorem. So Wilson theorem states that for prime number p to be p minus 1. So if we want that p minus 1 factorial, so this thing is divisible by this is the statement of Wilson theorem. Okay, now congruent to negative that if this is true, 1 is divisible. Now here as a cancel out 18 as a common factor on 1 mod 19. So that 17 factorial. So the next question asks me to find. So I have to do some statement that is 1. So I just apply here Wilson theorem 100 and 99 into 100. Okay. Now the next thing. This will be mine upon. Now what is the minus 2 mod 101 congruent to minus 1 by minus 3? So I get 97 factorial is congruent to 1 by 6, that is 6 inverse mod 6 and suppose 6 inverse, right? I can multiply 6 on both sides. 1 mod 117 x is equal to 101. So I get the value of congruent. So my remainder will be 17 more. Okay, so the next example 18 factorial plus 1. So how can I prove this? So when I think of 437 and when I try to prime factorize the 437, 437 will be prime factorized at 19 times 23 as 19 times 23. So if I prove that 18 factorial plus 1 is divisible by 19 and it is also divisible by 23, then I can conclude that 18 factorial plus 1 is divisible by 19 times 23, which is 437. So the first thing I have to, this is very easy to prove. I will transfer 1 on that side is equal to minus of 1. 18 factorial is congruent to negative. Algebraic manipulation in this to get to prove that 18 factorial plus 1 is congruent. Okay, 1 mod p minus 1 mod p. Now as p and p minus 1 are co-primes, I can cancel out the p minus 1 common factor there to get p minus 1 factorial by p, and it is also some a by 23 factorial, factor 1 power of 13 and 23 factorial that I have cancelled out will be the remainder of this to the question. Okay, now how can I find out the remainder when 23 factorial upon 13 is divided by 13? So this is 13 only. So how can I find out the remainder? So I will do one thing. I will write down 23 factorial by 13. I will break out this. So I can write down the 23 factorial by 13 as 1 into 2 into 3 till into 12. Now 13 will not come. 50 factorial. So 12 factorial into 10 factorial. So this will be theorem by Wilson theorem negative 1 mod 13. I have just before I have 13. So I can get out that 5, that is 13 into 5. It can cancel 10 factorial and 10 factorial 6 mod 13.